Hello. Okay, so I just wanted to do a quick video on, I don't know how I missed it, one of my most favorite things of math, the Pythagorean Theorem. So we had talked about some of those geometric formulas before that were on the SOL sheet. And we talked about area and perimeter and quadratic formula. And oh my goodness, I missed over here my favorite little thing hiding from me, the Pythagorean Theorem. So I just wanted to do a quick video about that. So Pythagorean Theorem has a formula, of course, because it's on a formula sheet. But the Pythagorean Theorem formula is a squared plus b squared equals c squared. Now, the Pythagorean Theorem, it must be used with a right triangle, meaning that one of the angles in your triangle must be equal to 90 degrees. It'll have your cool little 90-degree symbol, little upside down or right side up, depending on what way your triangle's facing. Cool little 90-degree symbol in there. You cannot use the Pythagorean Theorem on a triangle that is not a right triangle. So one thing that I think about math that a lot of people, I think that the reason they don't like math is a lot of times people are given something and you're told, this is the Pythagorean Theorem, this is the formula, you have to use it, memorize it and do it. And people aren't kind of given a little bit of a reason why these, theorems were put together and thought up. And so I just wanted to share with you something really interesting about it. So the reason that the Pythagorean Theorem works is, so Pythagoras, he was an old, philosopher way back, along with Socrates and all them. And he came up with this theory that when a triangle has a right angle, has that 90-degree symbol in here, right here, and then you put squares on each of the three sides, right? So here's a triangle, and then let's say you put a square on side A, and a square on side B, and a square on side C. Then the biggest square, this red one, has the exact same area as the other two squares put together. So this green square, the area of this one, the area of this purple square, when you add them together, will equal the area of that red square up here. Okay? So I think that's a really interesting way to look at it and kind of understand how, where Pythagoras was thinking when he was coming up with that and seeing it in a way, of why do we have, these sides labeled this way and why are they squared and what does that mean instead of just memorize this formula. This is what it is. I find that very interesting, just to see it laid out for you of why this theorem was created the way that it was. And why you can only use it on a right triangle. So now you can see kind of why, when you put those squares on there and finding those areas, that's in all technicality what you're doing to be able to find the sides of these triangles. Kind of what you're actually really doing is finding the area of these squares. So I find that very interesting. But, so, only can use it with a right triangle. And now we know why. Right here, it showed us, laid out. So here's some examples here of some right triangles, because sometimes when you have a problem laid out for you, they'll try and get you and trick you. Because oftentimes when you picture a triangle, a right triangle, you picture it sitting this way, sitting just right side up. You have side, A right here, your base is sitting on the floor, your, this side, which I'll say in a second, your the side C is facing this way, and it's very clear to see what side is what. But sometimes they will flip your triangles all over the place and try and confuse you a little bit to see, how well you can work this theorem and, use it in the correct way. Like this one here, even though this one right here, that's kind of like your standard look that you would picture for a right triangle, where you have side A, you have your base, side B, side C, we call that the hypotenuse. That is your longest side of your triangle. It's the hypotenuse, it's the longest side. Okay? Let's make that green and a bigger arrow right here. Side C is our hypotenuse. And let me label that. Sorry. I should have done that beforehand. Watch me spell it wrong. Hypotenuse. We good? We're good. Okay, side C, there's our hypotenuse. That is the longest side of your right triangle. So when they flip these triangles around and they try to make it look crazy so that, you know, hopefully maybe they can trip you up, they flipped this one the other way, right? It's like almost mirrored. That one's kind of easy to see. You know, you have your side A again. Your base is your side B. I always call it the base. Side B is sitting there on the ground still. Your hypotenuse, even though it's not facing this way, it's facing that way now. But it's really clear to see what side is what. But then if you look at this triangle here, that one got flipped around like crazy business. So what you need to do is you need to find that right angle right here. And then you can just picture it and look at it and think about it. First off, your hypotenuse is always going to be across from your right angle. So that will help you so that you can label side C. It will always be directly across from that right angle. If you notice here, here's your right angle. Zoop, there's your hypotenuse. Here's your right angle. Whoop, there's your hypotenuse. In this crazy flipped around triangle that it doesn't know what it wants to do, your hypotenuse is right there. So you can easily label your C. Now, A and B, it really doesn't matter. It really doesn't. I could make this B and I could make this A, and it really wouldn't matter. But I try to keep it the same every time, so that way I don't confuse myself when I label them. I always try to do, your B right here. Picture it flipped over, that's your base. That's what it's sitting on, And then you've got your A right here sitting straight up and down. That's how I like to picture it for myself. Sometimes, they might even, now I think things might go crazy when I do this. Yeah, because this was a hidden triangle. I've got stuff hidden in there. So when I turn this, ignore all the degrees and everything that are in there. But like sometimes they'll even take your triangle and have it facing like this. So you, again, have to find that right angle and come across like that. So the best thing to do is try and find that hypotenuse first, because it's the easiest one to find. Look at your right angle and come straight across. So you can label that triangle, write out your Pythagorean Theorem formula, and then start to solve. Just for some examples here, these are some there may be another word for it, who knows, I'm not an actual math teacher, but some non-right triangles that you cannot use the Pythagorean theorem on. What it means is that there is no angle in any of these triangles that equal 90 degrees. You've got an acute triangle here where it's a small degree here. Let's just say it could be 30 degrees, who knows, and then this one would be, I don't know, let's say one of them's 30 and one of them is 47. That would make the other one 103 degrees. That wouldn't work for this triangle. But none of those angles equal 90 degrees. And keep in mind, also remember that a triangle is equal to 180 degrees. All of the angles in your triangle will always equal 180 degrees when you add them all together, all of the corners. So if this one's 90, then this one is going to be a certain number, and this one's going to be a certain number, probably 30 and 60, to equal 180 degrees. But these ones here, if you do not have that perfect, beautiful L-shaped 90-degree symbol, then you're not going to be using Pythagorean theorem to be finding things out. You're going to be using something else. These right here, I hid things from you because I don't think you have entered that territory, but there's other ways to solve these types of triangles and whatnot. But I just wanted to point out to you that there's only one certain type of triangle that you can use this Pythagorean theorem on, and they are triangles that have a right angle clearly defined and shown to you in them. And we know why, because we looked at this and saw how Pythagoras came up with this. I'd really like to meet this dude because, how long did he sit there to figure that out? Good gravy. But let's get into really quick talking about a couple of examples and seeing how to use this Pythagorean theorem. So you have your formula of a squared plus b squared equals c squared. And I have an example here of a right triangle. And what you're going to do is, what I like to do, at least myself, is I like to label my parts first. When I'm labeling my parts of my triangle, it feels like I'm kind of getting a better image and am not going to plug something into my formula incorrectly. So if you are doing something on the computer, rewrite that triangle. Just draw it out really quick. And then you can label your sides. So in this triangle, the first thing I'm going to label, I always label, even though it feels backwards, is I label C first. I find that hypotenuse because I look for my right angle and I come straight across. So I can label, here's C. Okay. Then I am going to label the rest of them. So my B, I'm always going to label the one that's the base on the floor here. So here's my side B, my funny little pencil. All right, there's my B, and now I can label my A. It's the only one left, so, I mean, that's pretty easy, right? So I'm going to label my A. Oh, my goodness. I didn't know that would do that. Get out of here. All right, let's make this a capital A. Oh, come on. Am I really going to have to draw it piece by piece here? Thought I was going to make it easy here. Gotta draw it piece by piece. See, that's why I love paper and pencil. All right, so I've labeled my sides here. I've got A, B, C. I've got my hypotenuse labeled. So now that I've labeled them, I can start plugging in what I know. So let's get this formula copied here. Now, like I said before, keep on writing it. You begin your problem by writing down your formula and then fill in the first thing that you know. A. Do I have A? I absolutely do. Here's a 6. So I can fill in A. 6. So I will continue out writing out my formula. So 6 squared plus b squared equals c squared. Then I will take that all again and I'll write it down again. Because number one, going to keep me in line and keep me from missing anything and will also help me memorize my formulas. B. Do I have B? I do. Okay, so 8 for B. So 8 squared. There we go. And then I will continue writing out my formula. Now, do I have C? No, I do not have C. So you can leave it there. I mean, I know that they have an X here for C, and just so I can point out to you on a couple other things, like sometimes they just won't label anything at all. There won't be a letter. Sometimes they might use a different letter, but it doesn't really matter because you can just leave it as C squared because you know you're finding what C is. Okay? So now I will start to solve. Now, this can be a choice of yours. I mean, you can keep on writing out and just solve your first piece there, that's 6 squared, and then keep writing out that 8 squared again. Or since you've been writing it, you can keep it lined up here and know what goes with what. So let me copy this right quick. So you could get away with solving each of those first. However, so let's first right quick find out what 6 squared is, 36. And then 8 squared is, come on, 8 squared is 64. Let me move this over here so we don't get confused. Okay, and then I'll carry down that C squared. Now what I was trying to say was I would not recommend trying to, in your head, say, okay, well I know 6 squared is this and I know 8 squared is this, so I'm going to go ahead and add them together right now. I would write it down. Write down and write out that 36 plus 64 so that you can carry it down again and solve it. So we would carry these two together down and solve them. So 36 plus 64. And 36 plus 64 equals 100. I know I don't have my calculator up, but just so I can show, you know, you can use calculator, you can do it by hand, whichever one you're going to be doing. I'm not sure if you're being allotted calculator use or not. But anyway, so 36 plus 64 equals 100. And then I went ahead and carried down that c squared again. Come here. No. Move over. I want you right in line. I like it really lined up so I can see. Now, what we need to find is we have to find out what this side is going to be equaling here, the length of this side. So we have to get rid of this square because we're not actually trying to find the area of this square out here. We're trying to find the length of this side. Okay? So that means we have to get rid of this squared. And the way that you get rid of a squared, I know you can't see me, but I'm like doing quotation marks. The way you get rid of a squared is by using a square root. So you would use a square root on both sides, and it will leave you with just c, and it will tell you what the length of that side is. So I'm going to draw an ugly square root here. Here we go, square root, and we're going to square root again. Come here. Square root there on that 100. Ooh, I don't like it. Sorry, I just can't. I can't leave it ugly. Let's get a square root on this 100 here. Come here. Okay, square root of 100, and let's go ahead and do square root of this C2 here. Insert equation. Oh, it's not gonna let me. Probably because I already have an equation there. All right, so I'll just draw an ugly one. Shapes. Maybe I can try and be really careful and make it pretty. Here we go. It's still not that great, but that's okay. All right, so we have square root on both sides. So now we will solve. So first thing is, when we did that, we got that square root on that C there, it got rid of this squared. That was the point of doing that. So it's gone. Actually, we can just get rid of that altogether. So it got rid of our square root and just left us with C. So now we need to know what the square root of 100 is. Okay? Square root of 100 is 10. So that is our final answer. The length of this side, C, equals 10. Now, also remember, I don't remember if I put this on the video before or not, but if you are not offered any unit of measurement, you want to go ahead and have a unit of measurement there. So it didn't tell us if it was centimeters, inches, miles, pick a unit. So you would just say unit. C equals 10 units. And you can list it this way, or you can list it the opposite way, depending on what your teacher is asking you to write or how the computer has it set up for you to plug it in. It can be either way. It doesn't matter. As long as you're saying that C equals 10 units, because 10 units equals C means the same thing. So that is the simple, Pythagorean theorem right there. And then it can get a little bit weirder right here. This one's a little bit funky here because this time our triangle's facing a weird way. It's really weird. So we have to figure out and be able to label these parts in the correct way. So I am actually going to pause this really quick because I need to go and check on my children. So give me 2 seconds. I know it's not going to look like 2 seconds because I'm going to come right back, but pause. And I'm back. It's kind of funny because you don't realize how long I was gone for. But I'm back. So this triangle, as I was saying, they've got it all flipped around and flopped around, and it just looks like crazy business. Not like our usual, way that we like to see it. But we will start out with labeling our sides, and we're going to start with side C, like I said, because when your triangle is just looking all kinds of crazy business, it helps to go ahead and locate that angle, that right angle, and go straight across so that you can label your side C. So here is my right angle. Actually, I'm going to use a text box instead. So here is side C. Okay. Let's make you bigger. Side C. There we go. Side C. All right, because we found our 90-degree angle here and came straight across. Now notice this time, this one here did not give us anything like an X like this one did, or Y like this one does. It just has nothing, but we still know we have to find that side because there's just nothing there. So we're going to label that side C. Okay, now let's label our A and our B. So I'm just going to turn my head and picture it the way this triangle looks. There's my 90 degrees. Okay, so there's my hypotenuse. Okay, straight across. So I'm going to picture what side would be laying on the floor here. If I'm looking at it here. And we'll say here. So that'll be my side B right there. If I turned my triangle and had it facing, sitting on the floor. All right, so let's label my B side. Here is B. Okay. And let's make that a little bigger here. And change the color of it because we have this side. Let's make it pink. And now, let's go ahead and label. Don't be like that, computer. And let's label this side over here. Okay, we've got side A over here. Side A. So we've labeled all our sides. So now we can fill in what we know. So we will just keep on carrying down our formula and fill it in piece by piece. So we've got our formula here. So we have got A. Do we have A? We do. 15. So let's fill in A. And we're going to carry it down again. Okay, so that we can fill in B. Now let's fill in B. Do we have B? B. We do. 8. All right. And we are going to check here. Let's check now just because we want to make sure there's not a lot of reason to write it again. But we do not have side C. Okay, we know that. So we're not going to fill it in, write it again because if we would just write the same thing. But now we can start solving our problem. So like I said on our example up here, we could, solve each of these one by one and keep carrying it down, or I think you would be safe to do each one individually and then carry it down. But I do not recommend going ahead and trying to solve this one and then solve this one and adding them together. Okay, I think you should do this one, and then you can carry it down and add them together. So let's see what 15 squared is. 15 squared, I already solved this problem, but let me pull up my calculator just so I can see here. So 15 squared, 225. Here we go. 225. So 15 squared, 225. And then 8 squared, we have, I almost typed the answer in, 64. All right, so, whoa. All right, equals C squared. So now this is where I said that I recommend that you write each of these down. You solved them individually. You solved 15 squared. You solved 8 squared. And now we're going to add those two together. So 225 plus 64. 289. All right. So I'm going to insert, I'm going to do a text box here because, what did we say it was? 289. 289. 289 equals C squared. All right, let's make that bigger. Get on up there. Now remember, like I said, we are going to now have to find out what C is by itself, just the length of this side. So that means we need to get rid of our square root, okay? So that means we are going to square root each side of our equal sign, okay? So I am actually going to erase this only just because to do it on the computer, it's a little obnoxious. All right, 289, okay? Come here, highlight the whole thing. Hello. There we go. Square root of 289. And then we are also going to need to square root this C squared. Okay. So let's go ahead and set that up so it actually looks nice. I don't have to draw that ugly square root that I drew on the other one. There we go. All right. Now let's get my square root nice and over the whole thing here. There we go. So we have done our square root on both sides. Okay, so when we do that square root on both sides, what that's going to do is, first thing it's going to do is it's going to get rid of that squared, so we are left simply with C. Okay. All right, so now we need to know what the square root of 289 is. Now, using your calculator, okay, let's see. Now, I don't know on this calculator if I'm going to have to, let me see, 289. Okay, sweet. 17. Square root of 289 is 17. All right. Make that nice and big. And let's go ahead and fill this up with something pretty so we know it's our answer. Here we go. Side C equals 17. All right. So we do not have any units. Did it give us a unit? It did not. We don't have centimeters, inches, no nothing. So side C is 17 units. Either U or units. I'm just going to leave the U so I don't have to make my text box bigger. All right. C equals 17 units. Now, this example for Pythagorean theorem is where things get a little bit funkier. I mean, it's still the same concept, but there's one extra step in there that you're going to end up having to follow. Now, really quick, I'm actually going to steal all of these text boxes to make my life easier over here. This one, and this one, and this one, and this one, and this one. You can all come on over here. Oh, I didn't copy it. I am so silly. Still you, you, and you. Copy. And let's get you on over here. Aha! So I can get rid of this one. Whoa, 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 whoa. I don't need a design idea. It looks pretty enough, don't you think? All right, so let's fill in what we know here. All right, first, what we're going to do, I'm actually going to hide this for just a moment, okay? Only because... Oh, is it not going to let me edit it? Oh, well... That's sad. It's not going to let me edit it, really? Transparency. No. Will it let me hide it at least for now? No. Alright, I'll hide it like this. Watch me. I just don't want us to get confused with the numbers from the other project. There we go. Okay, so we'll hide that for just a second because I want to label my parts. And then from there, we can start editing things and filling in what we know. So let's label our sides here. So let's find our 90-degree angle right here and go straight across and label our side C. So let's label our... label our side C here. We have got side C. Let's make that stand out more here with red. All right, so there's side C. All right, so let's look at this triangle. Do I have something sitting along the floor? I do. So let's label my side B. Okay, right here, we're going to label side B. And let's label side A. Only one left. So here is A. And there's my side A. So now is when I'm going to go ahead and doing my formula here and filling in what I know. So first off, I am actually going to can I crop this? I can, because I don't really like how that carried that over like that. All right, so I have my formula, and now I'm going to fill in what I know. Let's start carrying things over. I think I'm just going to have to do text box by text box here. So I'm going to borrow this text box here. Let's fill in what we know. So, do we know A? We do not. Wow, this is the first time we didn't know A. So this time, do we know B? We do. It is 8. And do we know... Oh, you know what? Remember I said we're going to carry it down. Look, see, I was about to try and get all little Miss Smarty Pants over here and just start filling it in. But I could end up missing something. So we're going to carry it down. And now I can fill in what I know. Let's find C. Do we know C? We do. It gave us 12 for C. Now I'm going to go ahead and find out and solve those two things right here. These two areas for B and C. 8 squared is 64. I know we knew that, but I'm just going ahead and checking it anyways. And then 12 squared, 144. And you know what? Look at me. I didn't get rid of my squares. Because I don't need them anymore now, right? We just solved that. So I have A squared plus 64 equals 144. Now this is different than the other one, isn't it? If I look at this problem up here, the whole time I was always solving for C. This time they offered me C. So what I need to do is, to be able to solve for A, I need to get A all by itself on the equal sign, on the side of the equal sign, okay? Because we're looking for A. So we don't want to know what is, I mean, we do want to know what A squared plus 64 is, but to actually write it out and say that A equals something, you don't need anything else with it. So just like a regular algebra problem, I am going to minus 64 from this side and minus 64 from this side, or subtract. That sounds weird. Minus 64 from this side. I'm going to subtract 64 from both sides. When I do that, that is going to end up leaving me with closer. This will cancel out because 64 minus 64 equals 0, right? Yeah. So those will cancel out. So let's go ahead and just draw a line through them so we know they canceled out. You canceled out. Go away. Let's make you red so we know you're canceled. Okay. Those cancel out. And then let's see what 144 minus 64 equals. 80. All right. So we are left with A squared equals, oops, 80. And I'm going to move this over so that way my equal signs all line up there. So that way we know what's what. All right, so we have our a by itself. And a squared equals 80. So just like our other problems, we are going to need to go ahead and do a square root here to be able to get that a all by itself. So let's go ahead and square root this. Let's see, I'm going to copy this here. Whoa, just you. Just you. And change that to an a. Oh, not you. Delete. I'm so silly. I hope you caught me on that and we're yelling out, hey, hey, hey. That's not what we're doing. Come here. Let's copy this one. All right, you come here. Don't worry, I'll change that to an A. I just didn't want to have to go through all that drama of getting that square root in there again. Okay. And now we're going to copy you. Actually, insert text box. Okay. Equals. And I'll go ahead and do it. Ugh. It's so complicated to get a square root in here. Because you have to, when you're doing it on the computer, you have to click so many things and highlight so many things. Good gravy. But it definitely, I would say, looks better than the ones I was drawing, huh? Those drawing ones were just not pretty. All right, let's get that bigger. Here we go. All right, let's line it up. So when we do that square root, it's going to end up leaving us with a simple a. Let me get that a here. But the reason that I'm stopping is because I want to show you something on the calculator. How big do we have these? 32? Okay. I'm all about uniformity. A equals. If we plug in this square root of 80 into my calculator, let's see what it gives me. Oh boy. It gives me a decimal number. You know, it'll have a whole number, point, blah, 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 blah. So I know it is not a perfect square. So you have a couple of options when you are answering this question. You can leave it as a equals the square root of 80. You can say that. It's an acceptable answer. However, that is not in its lowest possible form. And I'm going to show you that because you have to look at how your question's asking you to answer it. Especially if you're doing virtual learning and you are plugging it into the computer, they're very specific. Because if they say this little sentence here of give your answer in simplest radical form, I know that sounds insane. All that means is what I'm about to show you with this square root of 80. When you end up having a square root and it gives you a decimal, you have to do a little bit of extra fun stuff. Because if you just leave it as square root of 80, that is not the simplest radical form of this number. And all that means is you are going to be breaking this down into a smaller square root in a way. I know that sounds funny. It sounds so weird. But to find these square roots of these, radical numbers, when you're having one that's not a perfect square, it doesn't end up as a perfect number of 4 or 16 or 10 or something like that. What you're going to do is you're going to take that number and you're going to break it down, almost like you used to, in middle school or, a long time ago, where you would take a number and start breaking it down into other, like what times what equals 80. So I know 100% that 4 times 20 equals 80. So I'm going to break that down. And I'm going to, let's make that a little thicker. Where you at? I'm going to break this down. So 4 times 20 equals 80. So 4 here. And I'm going to put a 20 over here. Whoa. And now we're going to look and see, can we break these down even more? What times what can equal these numbers? 4. Can I break that down more? I can. 2 times 2 equals 4. So I'm going to break that down. Two times 2 equals 4. Okay. Now, what times what can equal 20? I know. 4 times 5 can equal 20. So let's get that in there. 4 times 5 can equal 20. Four times 5 can equal 20. Now, can I break this down into another square root here? I can. We just did it right here, right? Oh. So that can be broken down. Now, does 5 have a square root, a perfect square root of the same number times the same number equals 5? It does not, because the only way we're going to get it is 5 times 1. So that can't be broken down anymore. So we broke down this number ridiculously, right? So what we're going to do is you're going to pull all these ones that we broke down completely, like there's no other arrows pointing down from them. Okay, and let's write those out. So we have 2 times 2 times 2 times 2. There's 4 2's, okay, that were all perfect square roots. Now 5 did not have a perfect square root. So that 5 is going to have a square root drawn around it because it didn't have a perfect square root. We didn't pull that down and make it into that perfect square. So let's get it with a square root around it. Okay, so we have to figure out what this 2 times 2 times 2 times 2 is. So let's see. 16. All right, now this is still going to have a square root though, just so you know. All of these. Double check. Yeah, all of these are having a square root around it. This 2 times 2 times 2 times 2. So let's see here. Let's just copy this box here. So that way you can still see it laid out. But 2 times 2 times 2 times 2 was 16. So that one gets a square root as well, just like this one. Okay. Oh. Okay. All right. So now we've done square root of 16 times the square root of 5. Does the square root of 16 have a perfect square? It does, I promise you. Because you just figured that out by doing that 2 times 2 times 2 times 2 is. So 16, let's find out what the square root of that is. 4. The way you're going to write your answer, okay, is the one that has the perfect square, this 16 here, 4 goes here. And then this one that does not have a perfect square is going to go right next to it. So your answer is A equals 4 square root 5. It really means 4 times the square root of 5. But this right here is your answer given in the lowest radical form. So what you have to really pay attention to with your question is how are they asking you to give your answer? Because if they're okay with a equals square root of 80, because they don't want that decimal there, or they don't, want you to break it down into the simplest radical form, I said lowest, simplest radical form, then okay. Or they might ask you to round your answer to the nearest decimal, or nearest hundredth. Let's say they ask you to round it to the nearest hundredth. What was the square root of 80 again? Something ridiculous. Okay, you'd have to round that to the nearest hundredth, which means you would be getting rid of all of these numbers here. So you'd be 8.94. Okay, so pay attention to what your question is asking you to give your answer in. If they ask you to round it to the nearest decimal, round it to the nearest decimal. Put that square root into your calculator. If they say that, you can just leave your answer as a square root, then you can leave your answer as a square root. But if they ask you to give your answer in simplest radical form, it means you must break this square root down the way we did right here with this cool stuff here. Okay? No, because last time I tried to circle something, it filled it in. But this right here is how we break it down into the lowest radical form. You take your number and just, even if it takes you a while, I mean, we may have been able to have figured that out a little bit quicker, possibly, but just start breaking it down. And then what you do is all of the numbers that are left alone, this one and this one, okay, this one and this one, all right, 2 times 2 times 2 times 2, okay, and then this one right here that was all by itself, couldn't be broken down right here, you're going to leave that gets that square root right here, okay. So we have square root of 16. It's like this is a different highlight, so it stands out differently. And then the square root of 5. Okay, so a equals 4 square root 5. That's when the Pythagorean theorem feels a little bit crazier. When you have to break a number down into radical form, or you have the extra step here because they gave you C this time and you're looking for A or B. That's when it can feel funky. Or if your triangle is all flipped around and know what it's doing. There is also, and I'm not going to go through it right now because this tutorial is already probably way longer than it needs to be. But sometimes they might go insane and go ahead and give you a question that has some parts filled in and you have to combine those like terms. Okay? So that's where it can get a little bit crazier. Or they might tell you, okay, so substitute x for A, 12 for B, and x plus 4 for C, Like, it can get a little bit crazier, and I can talk about that another time, but I just wanted to show with Pythagorean theorem the simple form of it with the a squared plus b squared equals c squared, and they are offering you regular numbers, and just show you the differences in how they can look, and then the difference between when your problem is set up and you don't know what C is, or if you know what C is and you're looking for one of these, how it's a little bit different. And I also wanted to show you what it would look like if your calculator is not going to give you a perfect square with your answer, and you have to break it down into that simplest radical form. That's what this means, where you're doing all this craziness and you've got a number pulled out and then you have your other square root here. Okay, so let me see something here. I just want to check in my calculator. Okay, and then second square root 5. Oops. Where's delete on this calculator? Here we go. Delete. Enter. I'm trying to think. I'd have to look it up and maybe I can show you on my calculator, because I know that there is a way to change this and be able to see it and double check yourself. So I can make a separate video for that. But there is a way to check yourself in your calculator to make sure that that 4 square root 5 actually equals this right here once you've broken it down. I just got to look it up because I don't remember. It's been a minute. I'm looking at my calculator. Anyway, I hope this was helpful for Pythagorean Theorem, because Pythagorean Theorem is one of my most favorite things in math. It's my most favorite thing in math because we learn it in, such a lower grade around middle school. And you don't know that once you come to calculus, how much you're going to come back to this Pythagorean Theorem, because you will. It's so great. So it's definitely something that you need to master. No, don't let those problems try and trick you. Don't let them triangles turn around and make you think the sides are something different. And then if you end up having to break something down into the simplest radical form, don't let that take over your mind either, because all you're doing is just breaking it down into these pieces here like this, okay? So I hope this was helpful on Pythagorean Theorem.